Hello, everyone. I am now recording for part 2 of workshop number 7. And let me just share my screen. And I'm here. So this is actually part 2 of the workshop number 7 because there was technical issue. We couldn't actually finish the, so I'm uploading part 1 and this is part 2. And this is workshop number 7. Okay, we stopped here when we talked about the contractual and expected rate. Now, I want you to understand this once and for all, because we will talk about it later on, but I want to tell you something. The issue of this formula is telling me that if I have $1, investing $1, I'm expecting that $1 plus some type of return. So that return can be coming from the risk-free. This can be risk-free. I can put it in risk-free. And risk-free means I can put it in central bank or anywhere. So like treasuries. Or I can invest it in group rates and then I will get my dollar and plus this K. This is a group rate if I lend to a corporation. And this should be equal if the corporation is 100% will pay me, because the difference between K and I is actually something called the premium. And the premium is for credit risk. So if you look at the graph, actually, it could be like this. If this is the risk, which is the credit risk in our case, and this is the return. So the risk-free is actually will cover the real rate, something we call it real rate. This is in the structure of the interest rate, and something also for inflation. So this here, inflation premium. And both of them, this is the inflation premium, and this is the risk-free. And from here, we can start. So all of this, which is the real rate, plus the inflation premium, is actually the risk-free, which is here. Now, the risk-free in this case is here. This whole area. And from here, we start something like the risk. So if I'm giving a corporation, if I'm having a corporation with this risk, then in this case, this defaulting risk, the risk now is the defaulting risk, okay? Is from here to here. Against that, I'm getting some return from here, this corporation here. So I'm getting this premium. This is actually the premium, which is the difference between risk-free, which is the I, and the K. So the K is here for this corporation. We'll call it corporation X, for example. I'm giving a loan for corporation X with this defaulting This is the probability of defaulting. This is the area of defaulting of the probability of defaulting of this corporation. Now, if we understand this, which means now the probability of defaulting of this area will need some premium like this. And this actually reflects this issue. So the premium is the difference between K and I, which is actually to compensate me for this probability of defaulting. And therefore, when I come back to this formula, it becomes like this: 1 plus I equals the probability of payment of my principal, which is the $1, and the K. And if I want to get something called the expected return, I will talk about the expected return later on. But the K actually now, the K is telling me that there is something called premium, which is this one. But when we come to the formula is saying, no, 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 no. We have more than that. We have actually, we need to take something called fees. When we give a loan, we have to take something called fees. This is against our administration work. And when we take, we have to take the premium. And we have to take, of course, the I, because the I plus the premium equals the K. So we need to take the risk-free, we need to take premium, we need to take fee, and we have to take something called compensation balance. And compensation balance is some type of the amount that when I give you 1 million in the bank loan, I will ask you for contribution. Say 10%, for example, or 15% or 8%, depends on the problem, which means, but you don't pay. So actually, I am giving you a loan for 1 million and counting for 1 million, but taking 10% or reserving 10% at the bank and giving you 90%. So actually, I'm charging 1 million for 900,000. This one, when you put it in the bank as your contribution or they take it from the loan, is actually no return for you. So you have to also count for that. And also, there is something else. When you come to me, to the bank, as a depositor, now the depositor, when he comes and gave $1, I don't take the $2. I cannot take the $1 and invest it. So actually, I have to give reserve to the central bank. That reserve, for example, in Malaysia is 2 cents or 2%, which means I have to use 90% of this only. So what I use is actually 90%, 90 or 90 cents, 98%. So so I have to carry this 2% over the borrower. I don't have to take this cost myself. I have to forward it to you. So we take something like reserve. See, this formula, the K now, is not only the premium, as we talk here, it's already more complicated, that one. Not complicated, but I have to, so the $1 now, the formula will look like this. The $1 plus the K should give me my $1 again, plus this formula. I have to take the fees, then I have to take the basic rate, which is the I, plus the premium. And as I told you, when I give you 900,000, actually I'm increasing, so I have to take the compensation balance to here, and this is the compensation balance, and then whatever there is This is how they, and this is the reserve. This is how the formula. So if you want the K actually, the K in the day will be $1 plus fees plus basic rate plus M, 1 minus compensation balance, 1 minus R reserve, and this one have to go back there, so I decrease the $1 I gave. And this is when you calculate the K. So I want you to understand this issue. So in this case, if you go back to this problem, you will find that now when they want me to calculate the K, is not only calculating the premium, the other things. So when I give you a problem, I will tell you, we are charging 5% fee. It's actually 0.5%, so it's 50 basis points. And we are taking, this is the compensation balance. This is the fee. This is compensation balance is 8%. Further sides reserve. So the reserve for the bank is 10%, which is in Malaysia now 2%, as I told you. Now it's 10%. This is the R. And then the basic lending rate is 9%. This is the PR, basic lending rate. And credit premium for specific borrowing is 3%. And this is the premium, 3%. So build the formula. I can build it now, and I find it to be 3. So this is -1, huh? The K now, I just take the 1 here and bring it back here. So it's -1. So it's 347. Now, this is how we calculate it. And I think by this, you already understand what we mean by probability, by the K. Now, I want to go now and talk about this. So if I come now and tell you, for example, here, if I tell you, well, if you know that the I, if I add to this problem, and I told you, which is the same problem, the I, if you know the I is 10%. And I tell you, this customer also give me a collateral of 50% of the loan. And I'm asking you to calculate something called expected return. The expected return. So the expected return is actually connected to the contractual. This is the contractual. This is what we call it contractual, which is this formula. The expected is egg, which is actually the probability of payment of 1 plus K. This is if there is no collateral, okay? Now, as you can see now, if I give you all this information, the issue is becoming complicated, because now the expected R is actually the probability of payment of 1 plus K, the K which I already calculated, 1347. But I'm telling you also, we have also a collateral, and this collateral will be used only if you don't pay. So the payment, either you pay or you don't pay 100%. So if the probability of payment, we have to calculate it. This should be 1 minus the probability of payment, which is the probability of defaulting. And I have to probability of defaulting of the K times the collateral minus the 1. minus 1, which is the $1. So now if I come now and I want to calculate, I have a problem. I don't have the B, but I have the I. From this formula, which I show you here, actually, if I know the I and I know the K, I can calculate the P. And if I know the P, I can calculate, this is the probability of payment. I can decrease it from 1 and I can get the probability of defaulting. So please look what I will do here. So I will first calculate the probability of payment. I mean, if I give you a problem like this, complicated, I give you all this and I add this information and I told you what is the expected return. So the expected return is all of this, I need the P. So the P is actually 1 plus I, as we agreed, 1 plus I equals the probability of payment of 1 plus K. I know that the probability, which means now taking this information, if this is 1 plus I, is the probability payment now. If I solve for I, it's 1 plus I over 1 plus K. I know the K is 1,347. And I know that this is 1 and this is 1, and I know this is 10%. Now, in this case, I am in a situation to calculate actually the probability of payment, which is actually, in this case, if I am not mistaken, 97%. If I am not mistaken, I think I'm not mistaken, okay? Now, if I know that, I can now calculate the probability of payment, which means I can get the expected return, which is, so the question here, if I give you this information, I will ask you, what is the expected return? So the expected return now, since I know the P, is actually 0.97 times 1 plus 1,347, the K, which I calculate, and then I have to add that to the probability of non-payment, which is 1 minus 97. And then I have to multiply this by 1 plus K, which is 0.1347. Then I have to multiply it by the collateral, then minus 1. If you calculate this, according to my calculation, it will be 11.76. I hope my calculation is okay. I just make it roughly. So I want you to understand that I can give you the contractual return and I can give you more information and ask you for the expected return. So please understand this. Now, sometimes also in these problems, the contractual, I can give you the K actually, because we have K, we have M, we have fees, we have premium, this is the premium, and we have a basic rate, and we have compensation balance, and we have reserve. If I give you, this is 1, 2, 3, 4, 5, 6. If I give you 5, you can calculate the 6th one of them. So in this case, I give you all the information and including the K. This is the K, which is, and I ask you to calculate for me. You see, this one, you know, 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 this one, you know. I just want you to calculate the PR. To solve for the PR is 12%. This is just one of the, you know, not really the games. So this one is this is not non, which I calculated now to be 12%. And this is non, so you can calculate. Okay, I think this is what I want you to know about it, about the contractual return, the collateral, the expected return, and when you calculate the probability of payments. Okay, now let's go to the credit scoring model. The credit scoring model is an issue which we actually use the borrower's characteristics to calculate a score representing the applicant probability of default. So why A is not right? It said the credit scoring is a mathematical model, consider borrower's credit rating. Credit rating, which means whether you are trouble A, this what we call rating agency is trouble A, until you reach to whatever D. So over 10 rating. No, we don't use that one. But what we use is the credit scoring. For example, the Z-score for Eltman is actually B1X1 plus B2X2 plus B3 until we reach. So there is nothing about scoring. We have the coefficient and we have the variable, and we just continue and calculate the Z value. So this is why A is not right. B, a credit scoring model is a model relies on expert knowledge. There is no knowledge here. This is judgmental, what we call it, judgmental. So number three, a credit scoring model is a mathematical model that absorbs borrower characteristics. Yes, it used, for example, here, it used the working capital, it used the retained earning, it used the total assets, it used the market value of equity, all of those characteristics. So this is the credit scoring. A credit scoring model is a mathematical model that uses natural works to make the loan decision. No, doesn't use this one. It's used the characteristics, okay? Neutral, we don't use neutral, we use the characteristics. Okay, now let me come to here and talk about the discriminant model. Remember, please, in the slides, we have three models just for the probability. We have the probability model, linear probability model. This is three factors. And it is where? It is in the slides, three factors, X1, X2, X3. And we have the logit model because this linear probability model have problems, so we use the logit model to solve it. And we didn't talk about the logit model. It's a statistical, treatment to make the Z between 0 and 1, because this one can be more than 1 or less than 0, which doesn't make any statistical meanings. So the logit model means the dependent variable, which is the Z value, will be between 0 and 1. You don't have to worry about those statistical things. So to limit between those ones. So the logit model actually to solve this problem. And then we have the Eltman, which is actually very famous one, which is 5 factors. And this is actually an international model. Okay. So as you can see here, this problem, you can just, because this formula will be with you, you can calculate X1, X2, X3. You have to calculate this and you have to benchmark it. So there is a benchmarking. Benchmarking means if this guy, if the Z-score between certain values, you accept it. And I will talk about this, the Z value, which we have talked about it many times. If the Z value between over 299, then you accept it. Between 181 and 299, you consider, or you make it to other committees if they're going to discuss it. And then in the third one, and then less than 81, you reject. Okay, all we need now is to go to these calculations. And I want to calculate X1. X1 is working capital, which is working capital, just to let you, it's the difference between current assets and current liabilities. Current asset 120,000, as you can see, and current liabilities is 60,000. So we are talking about 60,000. So this is the 60,000. This is 100, which means this actually 60,000 over 500,000. Okay, now X2, they say return earning. Do we have return earning here? Yes, return earning is ready, 112,000, and the total assets 500,000, which we already know it. Total assets is here. So I have no problem with this. It looks like straightforward. So I calculate it. Number 3 is the APIT. Maybe this one has some things that we have to consider. So if you look at the balance sheet, if you look at the balance sheet, for example, here, and I think I have explained it. This is the liabilities, and this is the assets. Because X3 is EPIT, and X4 is the market value of equity over long term. The EPIT, I don't have it. I have only the BIT. I have the profit earning before tax. But I wanted, so actually when you look at it, when you look at the balance sheet, it's the cost of goods, it's the sales minus cost of goods sold. Then we have what we call gross profit. Then we decrease any expenses we don't have. We have taxes. We have any expenses, and then we have the so we have the interest. We have admin, right? Then we have admin, we have to decrease it. Then we have earning before income and tax here. Before interest and tax. Then we have the interest. Then we have earning before tax. Now these people are telling me earning before tax is actually earning before tax is 250,000, which is this one. I don't want this one. $200,000, sorry. 200,000. $200,000, and the interest is actually 20,000, which means I have to decrease this from interest to get APIT, which means this one is actually 220,000 earning before tax. Earning before income and tax. You take the 20,000 interest, you left out with the APIT. Now I just make it here easy. I said earning before tax, which is profit before tax plus interest expense, which means I did the same thing, which is this one. 200,000, which is 200,000. 200K minus 2K. That will make you 200K. So now I get this one. Which is this one. Earning before tax. Interest and tax is this is earning before tax. And this is the interest, so at 44. The only thing here is the long-term debt, maybe it's not mentioned here. And the way to get it, see, The company's total assets, here total assets is 500, okay? This is what they say here, 500. Which means the liabilities is 500K, total liabilities and equity. Now, this is total liability. And this is total assets. Now, this one, liabilities, it would be current liabilities, which is actually 60,000 according to the balance sheet. Long-term debt, I don't know. But I know the equity to be book value of equity, 60,000. So, and this owes 500,000. So this is looks like to be 380. 380. So this one should be 380. Which is actually 500,000 minus 60 minus 60. This is what I did, you know, if you want to understand it. Market value of equity, you have it, and then the rest is there. So this is the only thing in this problem that if you are got confused to get those amounts. So we are done, and we get this 371, which is the Z value. Now I don't want to, but just to clarify the Z value, let's make it like this. You have Z value. Either this value is over 299. And in this thing, in this case, actually, you accept the loan. Or the Z value less than 181. And this one actually, clearly you reject. And sometimes they tell you the Z value is actually more than 181. But less than 299, which means between 181 to 299. The Z value is in this area, in the middle. And in this case, you just consider. You call it critical area. You call it critical area. I don't know, you need to go to another, it's not clear. You need to go to another committees, whatever, to approve this loan. So from this problem, if I look at this, based on our understanding, I didn't talk here about the accepting or rejecting. I told you just to calculate the Z value. But if I ask you, should I accept this loan? You will say yes, because the Z value is actually more than 299. It is actually 3.71. So you accept it. It's more than 299. It's more than 299. Okay. Now let me come to the second problem. The second problem, the first thing, accept or reject. Of course, you will tell me accept. Why? Z is over 299. I didn't ask you to accept or reject, but I asked you to look at to calculate Z1 and Z2. And this one is just very straightforward. You take the data from here, you apply X1, X2, there is no calculation, and you find it to be this one, which is 3.88. I don't think I should spend time here. And this one, I already talked to you about to the things and what does it mean. This is a multiple choice question. How do you interpret the 2.25, which is the critical area, which is between 181 and 2? And the right answer is this. The Z score lies within the zoo of ignorance. And thus a borrower may or may not be default, which means you should consider, I don't know, it's up to the, to the committees and all these people. There is some judgments here. But if you want to use numbers, science, actually it's less than the accepting area. but it's not very one like the 181 is already for sure. So the other ones is it's not safe. This is not incorrect. High default, no, this is 181. The interpretation of this score always depends on the financial manager's objective. This is no, of course. Depends on the score. Okay. Now let me come to here. We talked about the credit scoring. Now the credit scoring, as we said, we can have too many credit scorings, huh? We just talked about Eltman and we talked about probability modeling, but we can have a model like this, where they tell you the model is saying ZI is you have to calculate only two factors. And they will tell you what is the D over EI. So the D over EI, which is sales to asset ratio and debt to equity. This is debt to equity, and this sales to debt ratio. And they will give you the numbers like what they did here, and they will ask you to calculate. The only thing missing here, no benchmark. They didn't tell you what is the benchmarking for this model. So yes, you calculate the z-value, but it's then you have to know what is the benchmark to decide. Number like this is actually not very useful, but I can tell you this gives you an indication of the defaulting. Yeah. Okay. Now let me go to, I think I have explained this. No more to explain here. I explained term structure deviation. Yeah, coming back to the things which we talked about. Now, you remember when we talked about this? We remember when we talked about, I think you remember. And we just repeat what we. I think we have talked about this. And we said, this is the R. And the R can be K or I, huh? And this is the default, probability of default. Now, this is actually the risk value, and the risk free. And this one goes like this. I just make it another color. Now, if there is a company here, like here, the probability of payment is like this. So here we have 6% the risk free. This is 6%. And they told you the rate of one government crisis security is 6%. What is the probability of payment of the following security? Assume if the loan default, no payment expected. What is the market determined risk premium? The problem in the if you look at it in the questions, they are giving me here what would happen if the this is the K, the group rate for A is 9.5%. If I'm charging a company with trouble A 9.5%, which means, and the I is actually 6%, I can see they're defaulting, which means if I don't know what is the defaulting here, but I know now here, this is 9.5%. So actually the probability payment will be now here, 1 plus I over 1 plus K, or 1 over 106 over 1, and this make it 96.8%, which means this AAA company or customer with a AAA, when they give me 9.5% for their bonds they are issuing, I'm expecting 3.5%. I'm expecting for 98%. So I'm taking, this is actually, so the rate of defaulting is, for this defaulting, which is 3.2, right? I'm taking 3.5. So as you can see, for the defaulting, for a company with a default of 3.2 or a payment, a probability of payment of 96, I can take 3.5% more. This is just by concluding from the rates. The P, of course, will be higher, which means the probability payment will be less and the rate will be less. So in this case, if I calculate with the same thing, if they are paying 13.5, so we are talking about 1.06 over 1.35, and I find this to be 93.39, which means if you decrease it from 1, you will know this is around, I think, 6. Six, 61%. This is actually probability of defaulting. Now, but if you want to know what is the rate, this is the probability of payments, which means if you want to decrease it, they are taking 7.5 for a default payment of 6.61. Probability of default, they are taking a premium of 7.5%. You can come back to here and do the same thing. So this is how I want you to understand it. Maybe, I think I have explained this before when we talked about this problem, when we talked here and we explained all the issues here. When I explained all the issues here, when I explain all the issue here and I reach to this amount, this problem is just a replicating. But I make it now and you can look at it again if you like. This is when we have, the same thing, and we have probability payment and probability defaulting, and we have a collateral, which is this one, which is 50%, and we have a probability of defaulting of 5%, probability payment 95%, and we have the K of 10%. I can calculate the expected R. Now, sometimes, and there was a problem, I think, in the tutorial, in all the exams, if you are provided by the following data, so you have all of those issues, and you want to calculate the premium now, the premium, but I give you all these problems. I give you the P, I give you Y, I give you the K, and the I. Use this formula, please. When there is a collateral. See, when there is no collateral, the premium, when there is no collateral, the premium is actually K minus I. Let's go. But when we have a collateral, the premium will be like this. The formula will be like this. So P is the probability payment and Y is the collateral. You have to use this formula, which is 1 plus I, and then you have to bring the collateral plus the probability payment, and then you minus the probability payment by the collateral. And all of this, you have to minus it from 1 plus I. This is when there is a collateral. This is to calculate the premium. This is the last point, which is actually reflecting this problem, but I want to tell you something. And please understand what I'm saying here. If you are staying in the bank now, and you have a customer with a probability payment of 99%, two customers come to you, 1 and 2. One with probability payment of 99%, with one with probability payments of say 90% or say 50%. Do you think you will ask more collateral from 1 or 2? These people, this man, probability of defaulting is 50%. This probability defaulting is 1%. So actually, when it comes to collateral, this will be less collateral. I know this guy and he has been dealing with me and I know this experience. And this one is, I want higher collateral. Protect myself. Collateral means security. He can put an asset or bought machines, whatever it is a company. And therefore, if I talk to this, I can tell you that the relationship between the probability of payment and the collateral is negative, coming like this. Probability of payment is less, you need more collateral. Probability of payments is high, you need just this collateral. But here you need this collateral because his probability of payment is actually here and his probability of payment is here. See, this is what we are saying. So it's just, so we call probability of payment and collateral we call it either there are substitutes. You can use this, or you can say they have negative relationship. Can you prove this? Yes. Look, you can use this formula. For somebody who has a probability of payment of, if you have a collateral of 5%, so if you have a collateral of 50%, now the probability of payment will be 94. If you have a high collateral, then the probability of payment will be less. So the probability of payment when it is high, you have actually high collateral, low collateral, low defaulting. So in this case, when you have probability of payment of 50%, you need a 94% actually collateral. When you have a probability of payment of 95%, you need only a 50% collateral. Here, you need a collateral of 94%, almost the whole loan. this only you have the loan, 50% of the loan. This actually reflects what we are talking about. I am done here. Thank you very much, and sorry, really sorry for the technical issue, because when I was changing my devices, I lost actually the second part. The first part I already uploaded. Thank you and have a good day. Bye-bye.